So, if one of them wants to speak, what do they? I get some indication.
Yeah, they raise a hand.
And do I have to do anything?
Maybe press the red button, I think.
Well, but what if there's 3 people who want to speak?
I think it automatically sorts them.
Okay.
Do you wanna start?
I guess. You have slides.
So I'll do this.
Good morning. Welcome to 6-man session. We have a not completely full agenda, but should keep you busy. Oops.
There's a massive static spot.
I'm Bob Hinden. This is Oli. Go ahead.
Oh no.
Give us a second.
Yeah.
There we go. This is the note well, which I'm sure you've all memorized and always follow. We're still.
I managed to volunteer someone, so we now have Eric Winke as the main minute taker. Richardson is going to help him out, and Michael Abrahamson has promised to do the Jabber scribing. He gently asked you to use the front mic, so it makes it a lot easier for him to read your name badges. So please do that.
I noticed there is only a front mic now. Something magic happened. Yeah, so just going over the agenda, the intro we're doing now, I'll be talking about the IPv6 specifications, the internet standard. Then Eric Nordmark, neighbor discovery, RSRA refresh, then active individual drafts, router advertisement prefix information option from Eric, and then IPv6 node requirements revision or BIS document with Tim, and candidate encapsulation for Pierre, and then a late talk, Tim talking about whether we need to add the RA extension, some RA extensions to the Yang model for routing, but you'll hear more about that.
Okay, so document status. Agenda
batching. One agenda point. I think Michael and I had agreed between us that Michael would present.
Okay, that we will sort out.
Oh, you did. Okay.
What did he say?
That Michael is doing this one instead of Eric.
Okay.
Yeah. Okay, so for document status, we have published no documents since IETF 96. We have 2 documents in the RFC editor queue. It's the atom frag generation and the multi-homed host. The latter one, at least, I think both of them are in North 48 actually, so those are pretty much done. At the IASG, we have the default IIDs document, the obsolete MIBs document, and the 6106 BIS document, which are progressing. Suresh has a comment on some of these. Go ahead.
Yeah, so the MIBs actually went through IESG eval and it was approved. So it was waiting for like one change to come in, and Bill submitted it yesterday.
Okay.
So I'm just going to send the document through. So that should be in the RFC editor queue as of like today or tomorrow. So other 2 things I'm going to I think the 6106 BIS is in IETF last call, starting day ago or something. And IIDs, I'm going to push it to last call tomorrow.
Okay. So, and these are progressing fine, right? So there's nothing we need to. Yeah. Good. In working group last call, that has been going on for a while, as you know, is the core documents to full standard. Bob will talk more about the plan for those, but certainly the intention is to be able to advance these to the IESG within within a week or so after this meeting. We hope that we can resolve all our outstanding issues this week, put it to the mailing list, and then get them do the write-up and get them advanced. Then we have 2 documents that are in the queue for working group last calls. One that is presented today, which is the RS refresh. I expect one more revision of that one before we do a last call, and the max array document that has been in that queue for a while, and we'll get those 2 out. And there's one active working group document, which is the segment routing header, and then we have a set of new documents that we'll talk about today. We'll do a review and update the goals and milestones when we got these core documents out our way, and I guess probably at the next IETF meeting we should have a discussion on where we go next with this working group. So okay, Bob, I think you're up next.
So I'll go down and stand up.
Stand in the pink box.
Hi, of course I can't see the slides. Can you hear me? Good. Okay, next. So I have a bunch of slides which are the same as the last time I did this, so we'll just zoom through. But this is the project to move the core IPv6 RFCs to Internet standard. The Internet standard is defined in 2026. Next. RFC 6410 defines the advancement process, which we're following. Next. And there's all of the documents we're talking about advancing are currently at draft standards. So these are the rules for advancing draft standards. Pretty much the same, except you've already showed implementation experience. Next. And the process is a little unclear about documents that have been updated. So we are going forward with incorporating the updates. And the plan we presented earlier was to reclassify documents that require no changes and start working on updates. And then later we're going to look at, there's a whole lot of other documents, some of which can advance, but we'll, after we get this set done, we'll take a look at that and see what makes sense. There's a lot of documents that I think aren't getting wide use, but say something like IPv6 over Ethernet probably would be good to update. And given all the changes about interface IDs and privacy and so forth, that's I think probably worth doing. But they all need to be looked at. But but ones that aren't being used widely or at all, we can probably ignore. Next. So the 3 documents that are being updated are the IPv6 spec, the addressing architecture, and path MTU discovery. And we'll go over all of these today. Next. And the documents that are ready to advance are DNS extensions and ICMP. Based on an earlier discussion, we were originally intending to advance the privacy extensions, but I think there's agreement that this needs some work, and so we've decided to defer this. So this will not be requesting the ISG, reclassify this as Internet standard. Next. So I'm going to go over all of the changes that were made since the last IETF meeting. And so the slides are in this form. In this case, this was to, in RFC 1981 BIS, path MTU discovery, the change was to remove the text about RH0 since it was deprecated. And so you can see the text, and I, struck out the text that is being removed, just to make it clear to see what the change is.
And this is the last chance, so forever hold your peace if you don't stand up now and complain about it.
Well, there'll be an IETF last call.
Yeah, there will be. There's always a last.
There's always a last chance of the IETF. Okay, next slide. So there's only one change to 1981 bis. So this is 4291 bis. Several changes here. First is to remove the old IANA considerations, which was really just left off from what was in 4291 and no longer made sense in that IANA considerations are to tell IANA to do something, but they had already done it. But then also wanted to add that the IANA needed to update a number of references that are currently pointing to 4291. So I went to the IANA site and did a search to find all references to 4291. And then on the next slide, you'll see, so this is the IANA consideration section, and it's largely a list of everything that references. There was one it's in modify a port number assignment that came up with, it has a reference in it, but I don't understand why it's referencing this document. So, do you know the answer?
What was your question?
Oh, well, so there was one place, it's in the procedure for modifying a port number assignment that references 4291, but I couldn't figure out why it references it. So I think they should remove the reference, but they need to, we'll need to talk to them.
Dave Taylor, and no, I wasn't going to respond to that. I'm just thinking about your earlier point about how there was text that IANA had already done, and so you can remove it or whatever since they'd already done it. The text here is talking about what IANA will do.
Yes.
And so by the time that this becomes an RFC, would you expect this text to have changed? In other words, do we need an RFC editor note or something because, IANA should update and should be removed, and we want to make sure that once IANA has done the action, then when this pops out of the RFC editor queue, it says IANA has updated or it gets removed or whatever it is that we want them to do. So we should be clear as to what we want IANA to do with this text, not just what they want, but we want them to do with the registries.
So it's a good question for the reason being there is a draft that is going through the process about IANA consideration sections. And one of the things in it, it particularly talks about when you have an empty IANA consideration section. The RFC editor used to remove them, but IANA has requested that they stay. So I think this falls in the same, but that's true of all. What you're asking about is like,
what I'm asking is, when it gets published, do we want this to be phrased, do we want it to be absent, there are no further actions for IANA. Do we want it to be past tense? Okay, or do we want it to be future tense? And it sounds like we don't want it to be future tense by then, right? Maybe past tense is the right thing. Here are the actions that IANA performed would be a good thing for it to say. And so maybe we just need an RFC editor note as a CREF or something in the document to just say, please, RFC editor, please update the wording after the IANA wording has changed, which they usually do, but we want to make sure we call their attention to the past tense wordings here.
And it's certainly something to check in when we get to 48.
Exactly.
Yeah. And the last one,
I just want to make sure we all agree that we want it to be there and worded in past tense at that point in time.
That is true of all IANA when you give them actions, you're telling them what to do, but they're done when the RFC is published. Right. So we should look at, this also would be a good comment to the draft that's going around to say that, because then it'll be the defined procedure. And the last one was that I found a number of other things that came up that I couldn't figure out whether they were updated or not. And I don't list them, but they're really very procedural things. And so I think this will require a discussion with IANA, do the search, show them the other things and see what they say. I wasn't quite sure, or you can go do it yourself and see what else shows up. So. This is the current state of this. Okay, next slide. And there were two changes that related to what was originally the site local section, and these are indicated in draft 4 and draft 5. And so why don't we just go to the next slide? So this is the current section that used to be site local. You can see in bold is the new text. It left the third paragraph, which is the special behavior of site local. That's the deprecation that happened in RFC 3513. And this sort of says, the way to do this kind of thing is to use ULAs now. And that site local was originally the earlier version of this. And so this was all discussed in the mailing list, but this is the new version of this. I think this is good. Okay, next slide. This was to add a sentence and a reference to RFC 7421 about the 64-bit boundary. So in bold is the new sentence. Okay. And then there was a discussion about the security considerations here. And so on the list, we worked on a new set of text, which is to talk about privacy and to point to the documents that, talk about this in more detail. So I think this is a very good improvement over what was there before. Good. Next slide. Okay, so here's the series on 2460, and header insertion will be the last one because I suspect that will be more discussion. So there was a rewrite done. It sort of was done in two steps in draft 6 and 7. In the text about new extension headers, and I think the changes are all editorial from what was there before, but the three paragraphs are more consistent and read better. And there was some redundancy in the old text, and I think this is cleaner. Okay, next slide. So there's two slides that are similar here. So there were two error conditions. This is one of them. This is about handling of overlapping fragments. And so instead of it being in the main part of the fragmentation text, there's a section that was already there about errors that may happen. And so the text hasn't changed, but it was moved to the error section. You'll see another slide, a couple more slides, very similar. Okay. And there was I think this was part of Tim's review. There was to add the routing header to the list of required extension headers that a full implementation includes. So added routing to the list.
Refresh our memory, what was the basic, because normally when advancing documents, you don't add requirements, you only relax requirements.
Well, so we had taken it out. So it was, Tim. Yeah, well, so we had taken it out earlier, it was deprecated, but that was when there was sort of thinking that there was only RH0, but there are other routing headers.
Was it in the list in 2460?
Yes.
Okay, so that's what I wanted to make sure. I said this isn't added it to the list is a difference in 2460. This is a difference that reverts it back to what 2460 said in this list. Okay, thank you. That's
it was a change made.
I want to make sure that we're not upping the level of requirements in 2460. You can lower them, but upping them is difficult. So
right.
Thank you.
Fixing a mistake I made.
That was Dave Taylor, by the way.
Yes, it was. Okay. And then there was I did a similar thing about looking for IANA registries that referenced 2460, and so there were 6 more, or I guess that's 5 more that I added to the list. We originally had 2. Yeah, the search function on the IANA page on the IANA site was very helpful here. Okay. And there was a request for a clarification that to make it clear that no ICMP error message should be sent for in the case of receiving overlapping fragments. So that's the, in bold is the new phrase that says that. And this was the other case of.
Dave Taylor, just a question on that one. Is that what's observed that implementations already do? If so, it's fine. Or is this a new requirement?
I think.
Or is this purely an editorial change, or is this a technical change?
I think it's an editorial change. I thought it was implied in that it didn't say to send an ICMP error message. Usually everywhere else in the document, when it wanted you to send an ICMP error message, it says do this, and here it just didn't say anything.
So do we know what the Taki tests for the V6 Ready logo actually test? Do they actually test for this already?
It's hard to test for not doing something.
Tim is behind you, so he can.
So we don't actually have a test case for this, but I did do some testing, and this is one of the things I commented on, I think, 2 IETFs ago. And what we found is that people drop it. So this clarification is okay. I couldn't find any implementation that actually sent an error message. So I tried 10 different ones, so I think we're good.
I just want to make sure that this is going to cause existing ones to be non-compliant.
No, we'll probably add this test case when the biz happens, but I don't expect this one to cause any problems.
Yeah, I mean, it never said to do this.
Yeah, Tim Chan, the reason I raised it when I was going through it was that the 4 or 5 paragraphs above it all say and do something, and that says nothing, but so it should be.
Right, it could be misinterpreted. I think it's a good clarification. Okay. Yeah, and this is the other error case about duplicated fragments, and particularly the case that it may be the network that's creating the duplicates and that you may want to detect this case. And we wrote it this way, so it's not, it's saying you might do this, but it doesn't require it.
Hi, Tom Herbert. So when we say duplicate fragment, that means precisely duplicate, right? Not just the length and the
Yes.
offset, but the whole data. So an implementation would have to check it.
The case is the layer 2 has created an exact duplicate. Okay. And then there was a new paragraph that clarified how extension headers are numbered and which are upper layer headers. I think this is a good addition. I don't think it changes anything, but I think it, it's a useful clarification. And this is the new, there's a new paragraph in section 4. And we also expanded the security considerations. I think this is quite good. It's a big improvement over actually what was in 2460, which just says it's, has all the security issues of the internet protocol. And I particularly like that, we say you can use the security architecture, essentially IPsec, or you can now use encryption at higher layers in the protocol, which is, I think the IETF was a little overreaching when it thought all problems would be solved by IPsec back when this was done. So I think this is correct and a good improvement. Okay. So now for the fun part. So I think the last issue here is what to do about inserting extension headers. There's been considerable discussion, on the mailing list, face-to-face meetings. So after a lot of discussion, the chairs, with some consultation with our AD, we put together an online survey to get a better idea where we were, and also some hope that we would get more people to respond than we're just responding to the email thread. And so the survey was organized that there were 3 choices. First, to ban header insertion outright, and there was text in one of the drafts that did that. The next choice was to describe the problems that if you insert headers, and then the third choice was to say nothing. The survey was organized as a preference poll, so you could indicate 1, 2, 3, 1 being the highest preference, 3 being the lowest preference, we got, I think, 57 responses. So next slide. So this is the graphical view of this. So, so for the first one, you can see that for banning outright, 17 gave it higher preference, 11 the medium, and 26 the lowest. Well, you can read these yourselves, but you can see that there was a big peak in the describing the problem. And we got 57 responses, which I think was pretty good. And so the chair, we looked at this. We can go to the next slide. So we think that there's stronger support to describe the problem than the other two choices. And if you combine the first and second preferences, you get a clear, I think it's very clear what the preference of the working group is. So, you know, if you do that, then 53 out of the 57 people who responded to the poll supported this. And so I think that's, we think that this is the consensus of the working group. We also, with our AD's help, Suresh's help, he also initially ran a, how do you say that, Corda? Okay, Condorcet calculator, which sort of analyzes this kind of poll, and it also confirmed that B was the choice. So the chairs have declared that there's a consensus to include text that describes the problems with header insertion. And so we think this is a fair result. You know, this is clearly a contentious issue. There are, you know, fairly broad differences for all three choices, but I think most people would prefer this as the alternative.
Fernando Gont. My question on this poll is that I think that at the point in which you give among the options to describe a problem for something that is not really allowed, that's something like an implicit change. So, I mean, I have my personal take, I mean, on about these options, but I think that when you have a standard that eventually is supposed to not allow something, and then you allow what are the problems of doing something that is not actually allowed, I think that's kind of like an implicit change. So, I mean, I have no problem with actually changing the standard if the working group decides to do so, but I think that, you know, describing the problem of what happens if you do something that is not allowed in the first place, I don't think is the right thing.
Well, it was never outlawed in the first place. That's the problem. The document never, I mean, I think it's what the intent was in the document, but it never said you shouldn't do this. So I think this is the best, you know, there are strong opinions on both sides. And this is, I think, a reasonable compromise. It describes the problem. It essentially says if you do this, you have to worry about these issues. I do think that the next, I mean, I think this is the appropriate thing for this document, but I do encourage the working group to, I think we need a draft that goes into this, because we can't go into the whole, all of the details in 2 paragraphs in the base spec. I think we should write in, someone should write, or several people should write a new spec that describes this problem in detail and describes maybe alternate, well, whatever, and see if we can get a consensus for the working group in that. But I think this is the reasonable thing for 2460 bis.
So let's say that someone has never read 2460 and reads the 2460 bis document when it's published as an RFC. And let's say I read it and I wonder, you know, how the protocol works. And I say, well, are extension headers inserted in the network or not? I mean, are they allowed to be inserted in the network or not?
Yes.
They are allowed to be inserted. So I don't care that much about the outcome. I think that question should be answered in a clear way. Well, that's my take.
So, I mean, Suresh, please.
Okay, Suresh Krishnan. So 2460 never said whether extension header should be inserted or not, right? So anything we do here, we are moving this to standard, right? Whatever like we decide to recommend would be new behavior. You understand that, right? Because like there were, I know it was like clear to a lot of people, like one way, and clear to a lot of people another way, but it never actually went out and said like, you're allowed to do this or not allowed to do this, right? So if you decide to put in some text to ban it, that's new text, and that's not appropriate for standard, right? Especially since we have like no experience, like, doing this in a wide scale and have results about it, right? We know it's break stuff, and that's what is the breakage text describes, right? So that's the best we can do when moving this to standard. And as Bob said, like, if you feel strongly about, like, not doing this, the right way to do it is get a draft, get working group consensus, and we can do it like next week if you want, right? But that's the right way to do it, because the document didn't outlaw it or allow it in the first place, right?
I'm going to check something in your hand. And it doesn't really matter.
Mark Townsley.
Mark Townsley. It doesn't really matter what Bob meant when he wrote it. It doesn't really matter the text that was in the original document. What matters is what code was written and what's working on the internet. We often end up changing and evolving a protocol in a different way than the original spec stated. We have a whole RFC describing what this is called. Dave Thaler wrote it. So let's not talk about whether or not original 2460 said this or that, or what the intent was, or whether they should have or shouldn't have. We have to worry about where we are right now. Okay?
So what you're telling me is that we have a standard, and you wrote a piece of code that actually goes against the standard, and since you wrote that piece of code, we have to change the standard. That's kind of like the argument. I don't think that's the case. I mean, I don't think that's the way it should work. I mean, if you want to change the standard, propose to change the standard. That's perfect.
So this is why there's not a clear consensus in the working group to either leave it the way it was or to ban it outright.
And my other
Because
comment.
there are different opinions here, and what was the outcome of the poll is to describe what happens if you do this. Which
And
is,
my other
Can Suresh come in with a comment? And
Actually,
then Joe?
like, just to answer Fernando, it did not go against the standard because the standard didn't say don't do this, okay? So that is the issue, okay? So that's like done 20 years ago. Like, we cannot fix it now, okay? So the standard didn't say don't do this. And so people like interpreted it differently.
Okay, so let's say that I do address translation for IPv6. It's not explicitly forbidden either, right? But you're against that. Yeah, but that's not the standard track. So standard doesn't list like the whole possible ways in which you can violate the standard. It's like you said what it should be. So again, I think that this is implicitly changing the standard. I have no issues with changing the standard, but if you're going to change it, just say so. I think that we are pretending that there's ambiguity when there's not, and we are introducing like a way to do something that wasn't actually allowed. And the text that we're talking about is actually clarification that nobody thought that it was needed, because it was clear to everyone that you shouldn't insert extension headers. Now the question was raised, and as a result of that, I think that a clarification is deserved, but I don't think it's new text or new behavior. It's actually a clarification of what the original standard said. That's it.
John Brzezowski, Comcast. So either way, there's clearly, we're not all going to agree that, right. Some people say it's, maybe not 100%, or some people say it's permitted for some reason. Either way, it's happening. Okay. So one of the things that, this poll kind of, jumps out from this poll is basically, since it is happening, I can personally tell you that, from Comca's point of view, we're doing this, right? I think, the right thing to do, instead of, to kind of chronically complaining about like whether or not we're agreeing or not, is like, we're willing to step up and volunteer to help, address the B, right? Describe the problem. So happy, Victor and I were talking about writing a draft that describes more in depth one of the very specific use cases. Objectively kind of describing, the things, the kind of the, things that cautionary nature that people should be aware of. I don't really want to continue to have the conversation of like, are we doing, was this forbidden or not, or is it allowed or not? I mean, it's the water, it's under the bridge, the milk is spilt, right? Let's just, try to find a path forward.
And the document is, if the document, like it does say for a few other things, didn't say not to do this. I mean, no one thought it would happen, but
Bob,
it is happening.
Bob, as much as I'd love to say, I'm with you, right? I'm trying to be objective here and say, I want to give other people the benefit of the doubt, because I actually don't disagree with you, right? But at the same time, I want to give other people the benefit of the doubt, like Fernando and other folks, right? And say, hey, look, what? Let's just say there's ambiguity, right? Let's just talk about how we get through this and go forward, right? I'm kind of tired of having the whole this conversation forever, right?
I agree.
Can I just intercept here from the chair position? So the context there is 2460 and what we can do in 2460. there's clearly no consensus on banning the header outright. There's clearly no consensus on saying nothing. The best approach and the best way forward we can do, and we can argue over how good that consensus is to just describe the problem in this document. We can do whatever, and there's certainly no consensus and not in scope for this document to allow header injection or say anything on how you should do it, right? So in this context, in the 2460 context, from the chair perspective, B is the only way we have forward. So I don't think there is much purpose, to talk about alternatives, and I think it's too early to talk about. If someone wants to write other documents, both to describe the problem and describe use cases for doing it, that is certainly outside the scope of this discussion.
Lorenzo Colletti, I support this text. I cannot agree with those who say that it was not forbidden. It was forbidden, okay? You can't insert something without processing it. Like, I'm sorry, like you really can't, because you're looking at the bytes in memory and then you're putting them in the packet. So you can't.
So I don't think,
but I support this, and so what? Yeah, we are changing the standard. This is the working group where this standard is developed, and I don't see a problem with that. If we don't have, is there a procedural problem with this? AD?
But it's not you. So if you look at 2460, right? 2460 didn't say like you should not process it because it kind of didn't use 2119 language.
Exactly that.
No, it doesn't use like 2119 language. Okay, so that is like one of the. It does not. Okay, so like, okay, so that is really like the root of the problem, right? So I'm with the people who say it was not clearly specified. Okay, because if you believe it was like banned,
it doesn't use 2119 anywhere.
I understand, right? So that is part of the issue, right?
Well, we're not fixing that.
We're not.
Anyway,
and that's what I'm saying, right? Like, so like we cannot add like new requirements, like Dave said, when moving to standard. So that is a procedural issue. It's not. It depends. Okay, so like we're gonna loop on this because like
I have no problem with this. So I'm just.
I do have a couple more slides
so
here
if you,
too, by
if
the
you
way.
question what was meant, right, in the document, we're gonna loop forever because like people obviously read it in different ways. Okay, that's how I see it.
Tim Chen, so I'm perfectly happy with what Bob and Ellie have come up with here. I think it's a good consensus. But one thing I would say, and following on from what Lorenzo says, it quite clearly says here, with one exception, extensions headers are not processed by any nodal on a packet's delivery path. Let's maybe change that text since it's not now true anymore. Yes. That I think that needs to be updated as well, because let's go with the reality. I accept what John says. It's happening. So let's actually, make the text match what's happening.
The current text says more than that. It says if you're going to do it, go look at this RFC. It's not as clear as it once was. You have to read the whole paragraph. Well, but let's try to get through this.
Okay. And yeah, maybe that's.
Should not, and if you really want to do it, read this other document.
Yeah. And I think just a second comment. There is also, as an example of something that I believe does this, but it doesn't say so necessarily in the draft. There is the draft IETF 6-man segment routing header -02, which says, for example, at the ingress node of an SR domain where the ingress node receives an IPv6 packet, it encapsulates it into an outer header. I think it would be much better if that draft actually said what's happening and what people are doing and actually said inserted. Then we're actually all being honest and clear about what's happening. Perhaps that would be a good thing.
Just going back to what both of them mentioned, you have a piece of text in 2460 that you say that the extension headers are not processed. And here you're adding text suggesting that you can. That's a change in the standard. Now, you can change the standard if you want, but if you want to move this to full standard, then you have to have experience on that part too. And I don't think there is.
Go to the mic, Lorenzo, but this text does not say that you can insert headers, by the way. There's no proposal for that.
We do have experience. We have operational experience. Lorenzo Colletti, we do have experience with this stuff because we do it in the real world. Now, our standards were written 20 years ago, and they don't, in some cases, they're not up to date with current practice. So we do have experience.
Stefano.
Hi, Stefano Providi, Cisco. First of all, I agree with the conclusion of the survey.
Good.
I think the proposal made from the chairs makes sense, at least to me, it makes good sense. You also propose some text, which I think personally, I find it acceptable. So for me, we could close the issue here. Now, regarding a few comments that I've heard, especially about experience, if we consider that we lack experience, I think we should not write a single word about it. So either we do have experience and we can document everything, either we don't have experience, in which case we don't have to change anything and wait for experience. And this is one of the suggestions that Mark made a couple of meetings ago. Nevertheless, I think in the situation where we are now, after the number of emails we have exchanged on the mailing list and the time we spend on the mic here, I think it would be good to conclude this discussion with the proposal and the proposed text that you made on the list. Regarding the segment routing header draft, the segment routing header draft does not document header insertion. The segment routing header draft is based on encapsulation, which obviously also breaks MTU, but as many other encapsulations, because you increase the size of the packet.
Well, no, because the path MTU still works because the error messages go back to the encapsulator. So you can take action.
Or you fix the MTU value on the core, but nevertheless, it has been intentional not to have the segment routing header with header insertion.
Yes.
Now, if we agree that we should extend the segment routing draft, adding a section talking about header insertion, I'm happy to do so. That's perfectly fine.
But that should be addressed in that draft, not here.
Okay.
Right. Yeah. I mean, that's why I think the chair's recommendation is that it would be good for people in the working group to write a draft about this topic, because we can't discuss this in depth enough in what we could put in 2460, and then we can see what we can build a consensus around.
Okay.
Okay. So I have several more slides here, but go ahead. Go ahead.
Jelinkova. First of all, I fully support this. I think it's the best consensus we can get. And speaking of, we do not have experience and RFC says should not process, I heard exactly that text being used as an argument that firewall filters on a router should not do anything with extension headers after based header because RFC say do not process. So we do have experience with devices processing extension headers, and it's called access lists.
So I would. Oh, okay.
Yeah.
I'm closer now.
So Mark is the last one on this slide, I think.
No, the next slide.
Oh, this one. Okay.
For the record, I'm good with that text as well.
Okay, so this is the text that, with one small change, was what was in the survey. It's not in a published draft yet. I think it describes the problem and describes at least one way to avoid these problems. The only comment we got so this was sent to the mailing list, last week or so. So the next slide. So Jinmei proposed some additions to this. So I can tell you what I think, but I think this goes a little too far. I'm not so comfortable with the second paragraph. There was some comments from Brian Carpenter, who's not in the room anyway, that I think all we should do now is, as the consensus was, is to describe the problem. And I think this sort of talks about what might happen in the future. And I don't think that should go in the base IPv6 spec. Stuff that happens in the future will be defined in documents that the working group and the IETF approves. But the change, the additional sentence in the first paragraph, I think we just had a debate about that. So I guess my personal preference is to stick with the text on the previous slide, but we would like to get your feedback. So go to the next slide and then we can come back to this. So yeah, we would like to get your feedback on this text, or whether to make the changes that Jinmei suggested. And we would like to get some closure today, if at all possible, and then confirm that on the mailing list. If whatever we agree here, I'll be publishing new drafts with that text, hopefully today. And then we can start the process to advance these. So do you want to go back? I guess, any comments on this? Should we just go with this text?
Dave Taylor, the thing that I am pondering, and I don't know whether it warrants a change, and so I'll ask it here in case anybody else thinks that it does. Right now, the phrase about breaking the integrity checks, right? That phrase is technically only true if you add things that are part of the integrity protected portion, and not all extension headers are like fragment header.
The payload sizes.
So certainly the second, breaking the path MTU is obvious. That applies to every possible extension header, no matter where you put it. But the part about breaking integrity checks,
the payload size is part of the check.
Part of that.
So anytime you change the size, you break
okay.
AA.
All right, great. You convinced me that the text is fine as is. Okay.
Right, and
It
there
wasn't clear. It wasn't obvious to me. It might be fine. You've convinced me it is fine. Thank you.
And the text is trying to be written to indicate there could be other problems, but these are at least two.
Yes. Yeah. No, that part is fine.
Okay, good.
Tom Herbert. So I mentioned on the list that in the Linux stack, it's unlikely that we would undo header extension insertion. So it kind of is implemented now. But what this actually gives us is the proper documentation of why it's a bad idea. So I really like formalizing that. So we'll have it, but by the way, if you use it, it's really dangerous. It's a bad thing. Consider not using it. So this works.
And that's also why I think it's useful to write a bigger draft on this, because there may be other things and so forth. Tim?
Tim Chan, I think there's one way you could slightly rewrite the end of the first paragraph to make it read a little bit better is say, which can result in ICMP error message being sent to the source of the packet rather than the node or device that inserted the header.
Oh, that's a good idea.
Read a little bit clearer. And a comma after discovery maybe as well.
Yeah, I think that I struggle with that sentence as well. I
Something like that.
your modification. Thank you.
Okay, I think that's
Hello, it's David from Aeronox. I know there is a work, I'm actually part of it, that pushing, telemetric information in the hop by hop extension header, like, queue size, time stamping, stuff like that, definitely going to change the extension header. And actually it's work that's actually done in these days. So did you discuss with these people, consider that work?
Well, some extension headers, in their definition, allow the contents of the extension header to change. That's on a per extension header basis. So as long as it's done within the,
in the INT, for instance, but we change the size according
but
to
if
this
you
command.
change the size,
You
then
change the size of the packet. If you add, if you push metadata inside, you change it.
then it will cause all of these problems.
So,
and typically, so
this
in the
is a
IPv4,
discussion, if people from the hardware want to push and not to pre-allocate the size, want to push, every node have to, intermediate node have to push, his information inside.
but we're not going to solve the problem of header injection here. The way this is done in the IP architecture, if you look back in the IPv4 document, is that a host inserts a header which is empty, where routers can insert things on the way. But we're not going to solve the problem here. It's clearly out of scope for 2460. You can write about it in a different document.
No, but currently, actually, we're going to put a documentation, against, this, right? This is what? Okay.
We're just stating the set of problems, at least a set of problems, or an example of a set of problems that has to be solved if you were to do this.
Okay. So I think we will go with this text with the suggestion that Tim made to expand the last sentence of the first paragraph to say, or, why this happens. I'll work on that.
Okay, so then I'm going to ask Bob to make a revision with these changes. We're going to include in the write-up to the ISG that there was a rough consensus on this and how we have treated this issue in the working group. I'm going to put it on the list on the website, saying that this is now one of the topics, as well as the M and the O bits, that we're never ever going to talk about again.
Yeah, likely. Okay, so next slide. So this is sort of an update. This was in the previous presentation. So we've, we sent a plan back in March. We did last calls and requested reviews. We got reviews, changes were made. The next steps are to submit the 3 BIS documents for Internet Standard, and then to also request the ISG reclassify 3596 and 4443 to Internet Standard. So, and then we will be done with this phase. Well, it's not like we are done when you send stuff to the ISG. So there's a whole nother round of stuff that could happen, and used very rarely, I think, when you send stuff to the ISG, does it get through to the RFC editor without anything happening. So we'll see what happens. So we will work on the write-up for this. Good. Next slide. I think that's it. Good. Thank you. I don't see anyone else getting up to the mic. So good. Thank you. So then hopefully we're done by this, and we have these documents in the RFC editor queue by the next IETF. We'll see how that goes. So Eric, on router solicitation refresh.
Hello. Changing gears slightly. So this is a draft that it started working on a while back, but I said, oh, wait, what happened to this thing? So I resurrected it. So the document that's out there doesn't have any changes from the previous version, but I don't think we've gotten that much review for it. So let's go over where we're at. So the context is that we sort of started neighbor discovery in these protocols assuming that hosts will always be connected to this piece of Ethernet coax, 20 years ago, right? We, in addition, have these hosts that are in power saving mode, your average smartphone that goes into power saving mode and wakes up from packets. And then we have more sort of from the IoT side of things, or sensors or whatever, we have things that sleep on a schedule. And I think that we have good coverage for both the first two here. We have some additional things. We have RFC 7772 that was done in V6 Ops, basically making it a lot more clear about nodes that are power saving, that they can't ignore the multicast RAs, right? So that was work that we did a while back. But there's still issues with the hosts that sleep on a schedule. How should they actually behave? It doesn't say that clearly anywhere. And if you don't do this carefully, they could miss getting updated information from RAs. Because if they just implement DNA type behavior, it means that when they wake up, they send a unicast NS to the old default router, and they get back an NA and they say everything's fine, right? And then they send a few packets, or maybe have this in the next slide, and then they go back to sleep, and they never hear any RA ever, right? So, so if you look at these hosts that sleep on a schedule, suppose they wake up every 10 seconds, or every 10 hours, whatever the frequency is, they will perform this DNA, and then they will send or do whatever app exchange that they might want to do, send a packet, receive an ACK, and then go back to sleep. So they might be awake for a millisecond or a few, and then go back to sleep. So they would never hear this unsolicited RA, even if they were the receiver is turned on and they do receive these multicast packets, but the sleep schedule is such that they're statistically never awake. At some point in time, the resilient RS will kick in, because their default router is timing out. And then they will switch back to saying, oh, I should send an RS anyhow to get a default router again. But it's not until that happens that they're likely to find out any updated information from an RA with prefixes and lifetimes and whatnot. So the approach in this document is to decouple that by saying we have the router lifetime, the thing that causes resilient RS to kick in, and we separate that from this refresh time. So basically having a refresh time option in the RA saying you should at least make sure you refresh your RA information by sending an RS this often. And then as hosts wake up or when this time expires, they would unicast an RS to the router. And now they even if they sleep most of the time, they will find out about new information. The other thing that's in this document is saying, which I don't think we did in Resilient RS, is saying that when you receive a unicast RA, you should send a unicast RA back. This is something that 2461 allows, but doesn't actually recommend, right? It's sort of 2461 is more about, it's more efficient to collect up a few unicast RSs and then after a few seconds send out an RA, which adds delay to the whole process. So this is saying do a unicast RA immediately. So that's sort of the summary of what's in the document. And this last piece makes the DNA thing easier. Or for running these hosts, if you didn't do this send immediately part, a host would end up saying, I need to send an NS, a unicast NS, to make sure I'm still connected to the same router. And then I need to say, I'm going to send a unicast RS to do this refresh thing. And now I will get all the information. The fact that you can do both this stuff with just the RS-RA exchange means that there's half as many packets to do this when you wake up. So this is the option. The current thing is at a 16-bit timestamp, what's in the draft. That's what's in the document. The other thing that's there in the draft is when you send a router solicitation, you can actually say, okay, I support this RS refresh so that the routers can actually keep track. Do I have any hosts here that are not doing RS refresh? In terms of the things that are in the document, there's a detail around the actual timer, the number of bits for the timer. So right now the maximum value you can put is 18 hours because of 16 bits. And as you saw, there's actually plenty of reserved space in here. So it probably makes sense saying, okay, this could be 32 bits and you can have a lot longer time if you care about things that sleep for a very long time. And there's a minor suggestion from Jinmei on the mailing list, which I think just editorially clarifying things. The main thing, and this is why I'm standing up here, is to get you guys to read it to make sure that the document, because it sort of has had scope shifting a bit, right? That it's actually clear about the context that this does not affect anything for hosts that are just, for hosts that are in power saving mode, right? They can and should continue to behave the way they are. So I suspect that there's text there that we should actually delete or change to do that, but it would be good to get people to read the document to do that. And that's basically it. Yes.
Dave Taylor, question. And this is perhaps a request for text to appear in the document. What is the relationship between the router lifetime value in the RA and the refresh time, and how would somebody choose the refresh time based on that? Should it be the same, less than, what's the fraction? How do I choose? So if I'm picking a particular value as my router lifetime right now, and a particular value is, my reachable time and all the other values that appear in the RA, how do I choose this one?
Yeah, it would make sense to add some text about that, yes.
Like, should it be the same? Should it be different from one of those other ones? Should it be a fraction of them, but according to a particular percentage?
I think that it makes sense having it be lower than,
router lifetime is used to say, well, I want to send an RS ahead of time because that's how I time out things, and And if I don't see something, then of course I might choose to send an RS before the router lifetime expires to see is it still there or whatever it is, or I just let it expire, depending on whether I think that I'm actually receiving all the periodic RAs or whatever if I'm sleepy. And so trying to figure out what the right value is for that seems like it's very similar to the value for this, as that's kind of the closest proxy right now.
Yeah,
and having a discussion of that would be good.
There's probably some more thought needed there as well, because the router lifetime is max 18 hours, right? So if you sleep for 24 hours, there's no spec that actually says what you're supposed to do. When you wake up, should you forget that you ever had a router? Like, well, that sounds a bit silly, as opposed to trying to use the one that you had 24 hours ago, even though it actually is technically expired, right? And seeing, does it still respond? Yes. Yes.
Suresh Krishnan. So just to answer Dave, so there's another draft which relaxes the max RA interval to 65, not this one, but another one that's going to working with last call zone, right? And one of the sections in there actually talks about how you set these numbers based on what is your packet loss percentage on the link. Okay, so if you want something to move over here, we can do that, but that actually describes like using a constant of like what your packet loss percentage is to set how to derive the relationship.
It's 32 bits is bigger than 16 bits, I think is his concern, right?
Well, that and you need to educate the new reader to say, well, why isn't the router lifetime sufficient, right? Because here's what I'm doing with that one, and here's the problem of, and that's what causes you to need to use a different value. If it's a different value, right, then that helps to motivate how you choose the other value.
But there's still this thing that if these things, that's still a 16-bit value, right? So it might not make any sense to have this stuff be larger than 16-bit as a result. I don't think.
Lorenzo Colidi. So let's see a few things. So first of all, resilient RS does not kick in. It only kicks in on initial attach. I just looked at for 7559. So when you lose your default router, you don't do resilient RS, you're dead. So that's.
I thought we talked about that stuff. Okay. But, yeah,
I just read it. I mean,
says, yeah.
I thought, so, maybe I misread it, but I think that's what it was. So that's one thing. So you can't rely on that. For unicast RS, I agree that that's useful, but RFC 7772 already says should for networks that say, let's see, it says should do unicast RA in response to RS for networks that intend to provide service to battery-powered hosts, which is this case.
Oh, okay.
It already says should, so that one is fixed.
We added up.
Another thing, DNAV6, we looked at it, and I mean, I can't see how you would ever use that usefully. It makes a series of assumptions that are completely off the wall. Like, for example, if my default router is the same, then my prefixes haven't changed. I mean, that's completely.
Well, I think it actually does say that you should send an RA an RS in parallel.
In parallel, yes, but it doesn't. But like also, if somebody has taken your address, you don't do DAD for it. There's a host of issues. But I don't want to talk about that.
Yeah, let's not talk about that.
But let's not talk about that here. So I have other concerns here, and in general, I feel so. These are sort of the general position that I have on this is I don't think we should change the model in such a radical way, and I'm going to give a series of examples about this. So first of all, like the mechanism, I think fundamentally the mechanism here is a bit too weak. The idea that the network keeps track of who can and cannot support this is lossy, because you don't have a good way of knowing if a legacy host is on the network, because if it's a legacy host, particularly one that doesn't implement resilient RS, you don't know. You might miss 3 packets and then it's on the network and you don't know if it's there anymore. So, and by definition, it's a legacy host, so it cannot be assumed to be.
Yeah, so maybe that's a piece that we can actually take out of this document, right? And say the key thing here in my mind is the thing on the first slide that, well, these guys, and as you make it even clearer that these guys actually do die, right? Because if you read the spec, they're not ever allowed to send an RS ever again, unless you interpret it as, well, no, I really reattached the link or something, but they're really just sleeping.
To be clear, I think, if you have a situation where you can respond and you do respond to RS with unicast RA, then you can really get very close to the power numbers that you have with this, because you just send an RS when you wake up and you get an RA back immediately. And the only thing that you have to deal with is that. So,
well.
So,
but there is a question about if the host is really sleeping for 10 seconds, right? Do you want it to send an RA every time? Sorry,
No,
an
you
RS
don't.
every time?
No. So that's why 7.7. So let me continue then. So for example, so if you want to maintain working unicast connectivity, you need to listen to RAs while you're asleep, because
No. You're talking about the other device. The power saving devices already work. These are devices that they sleep. Whatever you do, they're not going to wake up for 10 seconds or 10 hours, whatever it is. So that's the context we're in. So don't confuse it with the power saving one. I think we already solved that one with the V6 ops document, right?
Okay. So in 7772 we have text that says, if you want to maintain working unicast connectivity, you have to listen to RAs when you're asleep.
Yes.
And the reason for that is that you can't send a TCP ACK if your default gateway has changed, for example. And so, or if your address has changed. So that is a problem here, because I think what we're trying to say is like, we're still on link, but we're not on link. We can't.
Yeah, but we're not maintaining connectivity.
Well, then what's the problem with just saying, I'm going to send an RS when I wake up?
Because it's inefficient if you sleep for 10 seconds. Nothing has actually changed.
Why is it inefficient? Like, you don't know if something has changed. Something might have changed.
But that's true even if you are connected all the time, but it's a radio. You don't know whether things have changed. You might have walked out of range, right? You might need to associate it with different AP. So there's plenty of things that can change in that world, right? But it's a statistical game saying, sure, if you're sleeping for 24 hours, depending upon deployment considerations, because it could be something that doesn't move, right? It might be radio, but it's a stationary environment. So even there, you could say 24 hours, the assumption is that nothing has changed. But definitely if you're sleeping for 10 seconds, the assumptions we make is that because that time is short, nothing is likely to have changed, right? And saying that each time you send a packet, you should be required to do an RS-RA exchange doesn't make any sense, because then we should do that for regular host as well, right? Because you don't know whether things changed a millisecond ago or a second ago.
Well, no, that's what multicast RAs are for, right?
But they're not reliable.
Well, you tune them to the percentage of packet loss that you expect, right?
Which means that you get eventual consistency, yes.
Yeah.
But you don't have, and the 10-second sleeping gets eventual consistency as well. Because we're saying we're giving you a time here. Pick your number, right? Saying that you will send a unicast RS every 10 minutes, right? So if you're sleeping every 10 seconds, or if you're sleeping for 10 seconds, wake up for 10 milliseconds, after 10 minutes, you will send an unicast RS and you will refresh. So we say there's an upper bound on the amount of time over which you could have missed new information, which is the same thing that we have for something that is actually in power saving mode, right? There it's based on packet loss probabilities, etc., right?
So basically, you're saying you want to save one RTT. You want to not keep the radio woken up for one RTT when you're about to send a packet. If you want to send a packet every 10 seconds, you don't want to spend that RTT with the radio open to send the RS and get the RA. Is that?
Yes, because the only thing you might send is the application payload. So instead of doing one application RTT, you would do two RTTs.
I get it. So you're awake for. So I think, yeah, I get that. I think it's a very narrow use case. So, like I said, okay, so one concern I had was the applicability when there are any legacy hosts. If we're gonna say, well, that's not in scope, then that's sort of
I think that simplifies things, right?
Yeah. So then we say, then I think I'm fine. Right? Yeah.
Yes.
It's really hard to tell if you have legacy hosts on the same link.
That's what you're talking about.
Sorry?
Yeah, that's what this flag in the RS is for, right?
I can go into details about how that doesn't work if you want.
Yeah.
So you don't know if, like I said, if you're relying on this flag and there's a legacy host that sends 3 RSs and you miss them all, then you never know that host is there. That host doesn't have any V6 connectivity, and that's a stable situation, never gets fixed. Because you think that there are no legacy hosts on link, so you don't send any multicast RAs, and that host is like, I don't have connectivity. Maybe it has V4 only, and it's dead, right?
And today, if it doesn't do resilient RS, right, it will get a multicast RA
eventually
at 10 minutes, whatever. An hour later, whatever it is, right? So sooner or later it'll get on the net.
Right. So so there's that. Also, it's basically impossible to exit this mode, Because as soon as you've gotten a legacy, or as soon as a legacy host has joined the link, unless you have layer 2 magic that tells you that the host is gone, you can never get out of the mode where you send multicast arrays all the time, and so you can. Sorry. That doesn't mean it's gone. No, that doesn't mean the neighbor cache. It doesn't. The neighbor cache expiry doesn't mean the host is gone.
But you can't talk to it until you ND it.
Right.
Therefore, you'd find out if it's there or not.
Well, you can send an NS for it. You can wake it up, assuming that it wakes up. So, like I said,
It doesn't wake up. It's gone.
Yeah.
I'm saying that the neighbor cache entry expiring means that the host is at least not reachable at that moment, which, as far as I'm concerned,
it strictly only means that you're not trying to talk.
I'm not trying to talk to it. It hasn't talked to it. No one has any communications. If someone wanted to communicate and the router finds it, then it's still there.
Yes.
And if the router doesn't find it when it had traffic for it, it's either still asleep and it's not coming back, or it's gone, which is effectively the same thing.
the neighbor cache entry is not per host; it's per IP address.
Well, okay.
Yeah.
So
So like I said, if we want to make this work, it needs a lot more work.
Microphone.
Well, no, but it actually, so it's not, there's stuff that I think we should delete, right? So if we get rid of this
All right,
R
so
flag,
if we delete
right?
it, let's not talk about it. All right, I think it's like in general, I think I'm fine with this. As long as we scope it narrowly to a network where you control the hosts and you actually are in a situation where it really makes sense to do this. Yeah. And I think, like I said, if you're in the case where you really don't have the power budget to wait that RTT when you wake up, and you can't fix that by saying, well, the RA is going to last longer and so on and so forth. That seems like a very narrow case, and I think it's fine in that case to say, well, here's a tool in a toolbox. Yeah. What I'm worried about is that people will get confused about this and say, oh, like I know how a push model works, sorry, how a pull model works. It's just like the HPV4, so that's what I'm going to implement, and we lose a bunch of benefits which we have today in terms of the ability to update hosts. Mm-hmm. And 7772 and has good guidance on how to make sure that the multicast array is not too power intensive. For these devices, it's basically a solved problem. We have code in the firmware now that does really pretty intelligent analysis of arrays. And even if you send it arrays every 3 seconds that change every 3 seconds, it knows how to filter them. Mm-hmm. So
yeah, I'm not concerned about those devices.
So let's scope it really narrowly to really, 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 really power careful devices, power sensitive devices.
Michael Richardson. So that's why I stood up, because my impression is that this document doesn't really apply to things like 6-fish networks where we are extremely not just power concerned, but we have like one broadcast slot every couple seconds. So that's why we're not doing multicast RAs if we can avoid them. And we already have a beacon that comes out every couple seconds. We're actually discussing how to put the RA in the beacon to avoid 2 broadcast slots. So we have very few broadcast slots at all. And so we also don't want to do the wake up and do an RA, but we can extend the lifetimes to fairly large values. So that's not a problem, right? So that's not a problem. So that's why I'm like, you're pushing down at the top and saying, I think this is solved for, you know, smartphone 3G connected devices. And I'm at the bottom saying, I think it's solved for really, really things below that. And so there's that sandwich, and I'm not sure there's anything left in between. Okay.
So 6-fish, you're putting this in the layer 2 beacons.
Well, we're discussing it. We're discussing
so
exactly.
It's not solved yet, but okay.
We're discussing that. We said, hey, look, it's really stupid to wait for several seconds for a broadcast slot to get the RA to find out where you are when you had to listen to the beacon to find out when the broadcast slot was, right?
So, but if this existed, why wouldn't you use this? Because the unicasts are too expensive?
Because we never, this is the first time, the first RA you would hear. We want to make sure that.
Well, no, but the first one you would do, 2461, you would send a unicast RS, right?
But we don't know where to send it to. We don't know when. We don't know when to send it to. When to send it, because we haven't heard until we hear the beacon, which tells us what the sleep schedule is. We don't know when the receiving node would be awake.
No, the RS, the solicitation.
I know. So the point is that the client, the new node, the leaf node, the host, until it hears the schedule, it doesn't know when it could communicate with the router. Okay.
Sure.
And so since it has to hear from the router, the schedule, we might as well also tell it the RA information, since, or some of the RA information, since there's not that much there we need. So basically talking about, so I have a draft that explains essentially how to put it into a beacon, but and it compresses an entire V6 packet, the whole RA into it. But the 6-dish working group said essentially, you know what, I don't think we want a general mechanism that transports V6 packets in beacons. So let's just put router advertisement options, because that's all we actually cared about. Okay. And so that's being discussed there. But the point is that we do that, and then we're actually going to do neighbor solicitations to talk to the router, and we can do that in unicast slots. Okay. And unicast slots are much more plentiful.
Yeah.
Okay, because they're limited in who has to listen. So all I'm trying to say is that I'm not sure that from the bottom coming up that there's a floor to where this document can apply, and I think that Lorenzo was saying that there's a ceiling to where this document applies, and it could be that there's nobody living on that floor at this point.
But that's specifically the 6-dish, right? Because if you
Yes,
don't
it's
have
specific to-
slotted or whatever, if you don't have slotted things, you don't have that need to get beacon information.
So in the general case of 15.4, you might be right. I don't think it's going to apply to Bluetooth or a bunch of other 6LoW things, because they have other layer 2s that do other things as well. So Bluetooth, so for instance, Bluetooth has a layer 2 that also has some things that happen, and BACnet is running over wires, and there's other things like that where I'm saying that there are other mechanisms already that
provide RA
that provide things that could happen. So BACnet, for instance, can only ever have one router. It's, I think, address 1 or 0, and it can never change just because of the architecture.
But you still need prefixes, right? You still
you still need a prefix. But the point is that you actually don't necessarily need to know when there can only be one router, and it can only be this host, because it's the controller, right?
Sure.
Go ahead. Yeah.
RA sequence number option. I suggest an RA sequence number option where you can put a 32-bit number coupled with the source address. You basically say this RA has not changed, and you can put 4 bytes in a layer 2 beacon, and you're done. You've solved this problem forever.
That would work.
Yeah.
Suresh Krishnan. So yeah, I agree with Lorenzo. We suggested this to 6-man like a few years ago, and we got beaten up. But that's the thing I want to have a sequence number in the array saying nothing has changed. Yeah, generation number, right. So the point I wanted to mention to Lorenzo was that there's like a section in the draft, like section 8.2 in this draft, which tells you how things can go wrong. So if you have something that's not indicated there, so what it really says that is like, if you don't know if legacy go away, don't turn off your multicast array. Okay, so if you look at it, and if you have any issues, just come back to it. Thanks.
I mean, I don't know that there. Yeah, so yeah, you can say like this can go like, you can say smoking kills, right? And that's fine. You can spend, I can say, can whatever, can cause.
You want to get rid of the cigarettes?
But I think it's better to like not really, like if we don't have a strong use case for this, then maybe we should say, oh, like you can do this, but it has these problems, right?
So I think what I'm hearing is, we should at least get rid of this, right? The R flag, and then that whole complexity of tracking. Do I have legacy on the link or not? Right.
But
maybe that's just because I'm only hearing a small number of people in the room. So
I would be a lot happier if this disappeared, because I don't see a good way to make it very reliable. And also, if we then scoped it narrowly to something, because like for many applications, literally once Suresh's draft to change the maximum array lifetime to 65,000 seconds is in, we're really talking about this node can't survive one packet receiving one packet every 10 hours, right? So that's kind of a limited scope as well, right?
Yeah, but there'll be plenty of them. I mean, one of them.
No, that's fine, right? But it's a limited scope. We could.
There'll be a lot more of those than there will be cell phones, right?
Yeah. But they're a category that we can scope separately.
So I'll figure out how to proceed, but because these sort of few people, or the people that are speaking up, seem to be mostly thinking that we should get rid of this R flag, right? But I would like to get broader feedback, so people can always talk to me afterwards as well. So thanks.
We should definitely take that issue or the issues that come up here to the list, Eric, and especially Lorenzo and Michael, if you could work with Eric on this. I was kind of thinking of volunteering you to do the review of the document when it was going into working group last call.
I can cut and paste the comments that I sent in 2015 in the adoption call, because that's what I said today. So I can call it a review.
Sure. I mean,
all right,
at least
I'll send them again.
Work with Eric to see if, what the common ground is here, and we're not going to send this for working group last call before we've resolved this. So at least one more revision, and then we're going to call for reviewers and volunteership. One last comment.
Question to Eric, just to put you on the spot. Is there any interest in this RA generation idea on your part, or does it sound stupid, or like whatever? What do you think?
I think I had it. I don't know if I ripped it out in this version, but because it was one of the open issues saying we could optimize this stuff by having generation numbers, right? And I don't know if that's worthwhile. If it's because there's some potential failures there as well. What do you do when do they wrap around? You have to worry about that stuff, right? So it's added complexity. If it saves bandwidth because you have 15 prefixes, whatever, and you need to send all of those all the time just to say that nothing's changed, right? That's inefficient. But yeah, I mean, but also that the RAs can now be smaller as well, right? At least the solicited RAs can now be small because it's just saying, here's your generation number, meaning nothing's changed, right?
So we're a bit over time. Maybe we can take this offline.
One last quick one, Suresh, or?
Yeah, so just to Lorenzo, yes, so I have a draft from a long time ago. I think I called it I'm awesome bit in the router advertisement. We talked about it 6 years ago. And I can probably pull that up if somebody wants to take it over.
You guys need to find a bar and have some beers and sort this out and let us know. They're too expensive. We can help you out with it. Michael.
Hello. Okay. Let's hope my voice doesn't crack up. I'm still recovering from a bad flu. If you wonder why I'm sounding like this. Hello. We're talking about the draft that me and Eric wrote up after some discussions on possible optimizations that a host can do if it realizes that it's alone on a /64. This is the 3GPP deployment model is basically a point-to-point link where the device is the only thing on this link. It has all the addresses, the entire /64. That's one example of this. We see it in other proposed deployment scenarios as well. It gives the advantage to the router that it doesn't need to keep state for everything that is in this. If you have a /64 and the host uses 1,000 addresses, otherwise you might need to keep ND state and so on for 1,000 entries. If this is a layer 3 switch or something, it doesn't have that kind of table space usually. So it solves that pair state, the IP and MAC information table explosion. It also saves that the host, if it understands this, doesn't have to do duplicate address detection and so on within the /64. It can just immediately start using whatever address it wants to use within the /64. And there are drafts to talk about power usage, savings and so on in this scenario. So the proposal is basically take one of the reserved bits in the PIO, and we call it the X bit here. And when that is set, if the host understands it, it turns off a bunch of functions that it would normally do according to the IPv6 spec. For instance, DAD and ND and so on. A host that is not aware of this can still do all these functions, and it'll not get the optimizations, but it will just work the same. So we try to not change anything else. So this is if you understand this, you can skip doing a bunch of stuff. If you don't understand it, you just perform normally. So we don't need to keep any of the, we don't have to keep track of who supports this or not. So if you understand this, there is like language of, okay, the X bit is set, then you should treat these flags as being set this way.
Sorry, Michael, there's a comment on Meet Echo that the mic is low. Maybe you can get a bit closer or something.
Closer, okay, sorry. So then you should treat it like this. I don't remember, Eric, was this a must or a should? It was should, right? Oh, okay, come back. And then you turn off a bunch of functions, and we try to change nothing else. So we're a must. Okay, there were a lot of discussions on like how prescriptive do we want to be, but we try to not change anything else. And if we want to later do something more with this, then that would be a separate document. The whole router behavior and state, and if the device goes away and how long and so on, this has been also a lot of discussion, so we would like feedback on that. I'll come back to that at the end. And we're also writing that this is not supposed to be done to do like advanced routing scenarios and so on. This is deployment scenarios to a host, and it's not supposed to set up like hierarchical routing of some kind, or that's not what it's meant for. If you have insight into the link layer, there are possible ways of saying, okay, I know the client is gone, it's not coming back, so I'm gonna say that this /64 is now unused again. But otherwise, we believe that you probably must keep according to the rest of the lifetime of you must keep this reservation or allocation or whatever you call it.
Could I ask you a question on the state issue?
Mm-hmm.
Do you have any mechanism to maintain the state? For example, with an RS refresh.
So there is text on this. Okay. This is one of the things that we're not 100% sure that this is solved as written right now. So this is something we would definitely like feedback on the whole state machine and how do you, like, we've been toying with the idea of, can you do NUD with a link local address and this way discern that the client is gone? But if it didn't respond to that, did that mean that, I mean, it might still think that it has these addresses, so it might not, work. So we would like a feedback on that part. And so we had these were the issues that were raised during the call on the mailing list. So the persistent state, if the router reboots, what do you do? If the device changes its MAC address, what do you do? And also there are other considerations that we actually haven't looked into. SAVI is a IETF working group that is not getting enough attention, but it has to do with inspecting RAs that's flying by and installing like anti-spoofing filters and so on. We haven't looked into that. And DNA, I think, was mentioned here before. Is there anything there that we need to look into more? Okay, there are people at the mic. Do you want to go now or? Yep. Yeah, there's like a future work thingy, but yeah, okay. There you go.
So Eric, not Mark. So in terms of when you time this out, right? You could do the SAVI approach of saying, I'm going to send a unicast, whatever, NS, ping, whatever type thing, saying, are you still there? And so you just have to, are you assuming it's the soft state approach of, well, the host isn't reachable right now, but it's just because it walked behind the concrete pillar, right? Yeah. And so it will be there later. Yeah. So you have to potentially do more than what SAVI does in terms of saying, okay, I need to try over some amount of time. I space out and I do 3 of these over whatever, 10 minutes, right? And if it didn't respond then they say, okay, it's gone or something. But figuring out what's the model that you use for that deletion is a soft state approach. Otherwise, you have to turn it around and say, no, the host has to keep on refreshing this somehow, right?
Yes. So
I think that those are the 2 models that you could do for managing the state.
Yeah, but I think that since you're actually sending this array unicast to the host, we start off by seeing an RS. So this is why, but my thinking right now is that as soon as you send the array, you have now basically said for the lifetime of this array that this binding is now valid.
Oh, the prefix lifetime, okay.
Yeah, exactly. The /64 PIO.
Sure, yeah,
lifetime.
but that might be a very long time.
Yes.
If you're going to keep the current, 30-day whatever time limit.
So,
Default, right?
so there are probably, we need some text on that, and so the question is, do we put that in here, or do we write a v6 ops document that tells you how to actually use this? I would actually like it to do it that way, to give guidance on different deployment scenarios for this, because as we discussed, I mean, it's different if it's a wired network or if it's a Wi-Fi network or a battery powered something. I don't know. I think that there is no one way of doing this.
The intention here is to not require a backend DHCP-like server here, right?
Correct.
So I think the client has to ensure that state is in the forwarding device.
But sure, but you can say that it's there for whatever lifetime, even if that's 30 days, right? So the client then, after 30 days, needs to refresh it, right? So I think you still need a mechanism that has some refreshing in it.
Right. That's valid, yeah.
Well, but then after 30 days, what happens?
No, well, do you wind up? Yeah.
Yeah.
So,
or what happens when I crash? I have no
Lorenzo
persistent
Fellini.
storage.
So I would suggest heading off this discussion entirely, and I don't think we can fix that in a way that's not very messy. And I wouldn't attempt to fix it. What I would suggest is that instead, we initially decide to specify this mechanism only for link types where we have a solid indication from layer 2 that you're talking to only one device, and that device is or is not still there. Now, examples of those links, which are very common, are Wi-Fi and 3GPP. So I think we can make a whole lot of progress. There you are. So any type of link that has a strong layer 2 indication that there's an existing session, and like in Wi-Fi, you've got deauth, right? So you know that somebody is not there anymore. I would suggest initially specing
Or
it.
after a minute or something, yes.
Sorry?
Well, if a Wi-Fi is not answering after a minute or something, I don't know, then you know it's gone.
Right. So anywhere where you have a layer 2 indication about this, I would say that it's much easier to solve this problem, and there's a lot of benefit because those links are actually fairly common in some scenarios, right? Wi-Fi and 3G, they're pretty common. And I think the 3GPP has already been doing this for years, because what they do is they send an array with an infinite lifetime, and that's what's written in the spec. And the semantics there are, when you disconnect, that's no longer valid, and when you connect again, you have to send an RS again. So I think, and I think that's all these problems are going to be very complicated to fix. But if we do it based on layer 2, we say, well, we don't specify what happens on non-layer 2 links. Right now, this is specified only for those types of links, and we get rid of all these problems. We also don't have the problem that we need to do NUD. We don't have the problem that when we basically in the draft we say, well, like you should switch from multicast array to unicast array. That means like if the link local address changes, you have a problem, and so on. I would just say do it for these types of links. Additionally, if you do that, what you can do, I think, is you can reduce the state in the router to a prefix comma MAC address tuple, which occupies less space than a prefix link local address MAC address tuple. So you basically, when you're moving to something like this, is something that John and I discussed yesterday. When you're trying to do this on something like a cable network, you can basically do this without increasing the amount of state, and even by reducing the amount of state.
Yes. So actually.
So it's like where it says like similar to DHCP6 PD. Well, okay, after reboot, sorry. But yeah, so after reboot, like again for layer 2 in layer 2 integration, you know that the client's gone.
Yeah. So I think that optimization of not even using the link local address is perfectly valid for where you have a MAC address.
Yeah,
not all like
or when you point to that sub
doesn't work.
interface, right? Whatever layer 2 attachment point you have, that's what you point
so
to.
So it's interface and MAC address. If you have a MAC address and it's interface, it's just interface.
It could be a sub interface, a VLAN,
exactly.
a PPTP tunnel, whatever.
Yes,
right?
exactly.
So, Christian, just a question to Lorenzo. You said get rid of NUD. You cannot get rid of NUD.
No, I didn't say that.
I heard you say that. So that's why I was like, okay, you cannot get rid of NUD because it's the prefix, like you're making it exclusive, right? Like any address you form, you don't know if it's there or not. So we need to do NUD.
No, sorry, I didn't say, like what I said was you don't have to rely on NUD to figure out if you have to send an array or not. I don't think that's a good idea. I'm not saying that we should get rid of NUD at all.
So Eric Nordmark, I think, restricting this to a set of link types, yeah, that's one way forward. But I think that some of the examples, like Wi-Fi, well, the L3 and L2 entities are typically not co-located, right? So your access point would know that this thing is now gone, but it has no way of telling that to the router. So, well, but the scoping statement becomes complex, right? We can clearly say if we have a GTP tunnel that terminates at the L3 device, sure, you can do this stuff. But the other ones you have to describe and maybe come up with a signaling mechanism to say, this is how the L2 part can actually talk to the L3 part, so it's gone.
Sorry, do you mind if I respond to that? Go ahead.
No, it's okay. Go ahead.
So, okay, to respond to that, I think the requirement doesn't have to be complicated to write. It can simply say, it can simply state it in terms of requirements that the link layer has to satisfy a set of requirements, like you have the ability to know when a host is gone, and you have a clear identification point. And it's true that in general in Wi-Fi you might not have this. In many cases in Wi-Fi you do have this. Like for example, when you have an integrated access point in the home, right? For example. Or in an enterprise network when you have a Wi-Fi controller that's keeping track of hosts, right? In those two scenarios, you do have a strong sensation that the or a community Wi-Fi, a public Wi-Fi network, where you have this enterprise-like thing, you know for sure that somebody's gone or not, right? Because there's all sorts of security state about that. Like for example, have you logged into the captive portal, and so on and so forth.
Could you go back to the previous slide? I noticed that this says that
so
it seems like
we're going to have to close the line. We're
Okay.
sort of out of time, but the two of you, go ahead.
James Woodyard from Google. I forgot to introduce myself. So this second bullet item says what to do if the device changes MAC address, perhaps for privacy reasons. And I looked at that and I said, well, seems like it's much more likely that the reason a device would change its MAC address is because it's registering with a sleep proxy. And I thought to myself, so how does this whole thing work when you are trying to register yourself with a sleep proxy? And can that be made to work? And I just noticed that David is currently about to bang his head on the table, so I think I'll walk away.
Okay, that did not help me at all, but okay.
If you change your MAC address on Wi-Fi, you're gone.
Yeah, that is probably what we have to conclude.
Alex Petrescu, with respect to the Wi-Fi, with so point-to-point links on Wi-Fi, such a thing may exist, but I noticed in the public hotspots that more and more public hotspots no more use security tunnel, CAP. So I think in general, one would expect less point-to-point links on Wi-Fi, at least in the public hotspots.
Then they can't use this.
Sorry?
Okay. Then they can't.
They cannot use this.
Yes, right.
Yeah. So.
But it's like if they want to scale, they will have to change, because
no, I would say vice
model.
versa. I think.
Okay.
Yeah, I think point-to-point links don't scale. So then with respect to this being a good idea or not, yes, looks like a good idea. Put a exclusive bit in the PIO to say that this is exclusively for you, but not only for you, it's for you, for the host, and for me as a router. Okay, this is so it's not that it gives 2 to the power of 64 addresses to the host. It at least keeps one for itself.
No, the router will not have an address in this space.
Well, I think in some 3GPP links, yes.
No, GGSN does not have an address in that space, as far as I know. Yes, if it's not exclusive, then you're screwed. That doesn't work.
So this looks like we put a requirement on 3GPP to not configure an address within this prefix.
As far as I know, that is how 3GPP is done. The GGSN does not have a GUA address within the client prefix. Yes, it's been like this forever.
It is.
Yeah, but anyhow, the router has to route this to the link local or MAC address, and it cannot have an address in this space because then it can't use the XBit. So in
I think
expectation
up to now, the 3GPP network could say it would use a address in that space. No. Okay.
Okay, last slide.
So I think I mentioned this before, that this is what we're currently considering, and that needs to be done before we can proceed. But yeah, so I think we can take it to the list after this.
That sounds good. Thank you. I think we passed that one. So Tim, please come in the pink box. And there's a clicker for you here if you want it as well.
Okay, so good morning, is it? I think it is. So we've got 15 minutes, I think, just to discuss what we're doing here in terms of updating the IPv6 node requirements draft. So this is an update, therefore, to 6434, which was published in 2011, and that itself obsoleted a previous version from 2006. Obviously, a lot's happened since 2011. There's been a lot of deployment experience in particular, but also a number of new RFCs have been published. So understandably, there's a number of updates that we can make to this document. What we've done so far is to speak to the previous authors to make sure that the new author team is all good, which we've done. And we've published a first draft of 6434 bis. We've not changed any of the text in there. What we've done instead is to add notes in the document with the little magic marker ** bis ** and put little paragraph comments in there. And the idea of that is that we can then go through the document, agree what we think the changes will be at a more sort of high level before we start editing the text. We have updated, obviously, the authors and the acknowledgements, and there will be obviously a number of additions, deletions potentially, and changes to make. So we've looked through publications that have come out of 6MAN and V6 Ops and OPSEC since 2011 and worked notes from those into the document. There are obviously other working groups that may have relevant things, and if you're in one of those groups, please do suggest things if you see that they're missing. As I said, we've put these markers in the document, ** bis, so you can just search through the bis document to find out where those are and to look through them and see if you agree with them. There's currently 44 instances there of that. And again, what we'd like to do is get consensus on what those changes are before we start hacking away at the text itself. So some examples of the changes. Obviously, there's updates for the things that Bob was discussing earlier, 2460 bis, etc. Things like atomic fragments, the various IPv6 extension header stuff, optimizations to NUD and RA, and some of the things you've been hearing about again today. The introduction of 6LoWPAN is something new since the 6434. Probably remove A6 completely, and there's various other things that have been published and clearly we should be putting into this, or I say clearly, the authors believe we should be putting into this document. So those are the type of things that we're adding. We've had already a little bit of feedback on the mail list. So I think it was Geordie that asked about it, whether we should add details of transition mechanisms, and I think the consensus there was not to do that, but if someone wanted to write a separate draft on transition mechanisms, have a go at it. There was a suggestion to mention draft IETF 6-man multi-homed host, which we agreed to, so that will go in there, and a suggestion to add a couple of appendices. I think these were from Brian Carpenter, maybe, to have a list of obsoleted documents and a list of other reading. I think we agree that the authors agree that those are good ideas. Obviously, we'd love suggestions for what that other reading would be. Some further things that we're proposing to do. So this is the point where you might want to come to the mic and throw things. Adding a note on the use of 1280 MTU and PL MTUD. There were certainly some strong comments made in 6-man last time by, I think it was Mark Andrews and Jeff Houston, about 1280 MTU in certain circumstances, for example. We can add a note on the Y64 draft in the part of the document about addressing. We should certainly clarify 4862, etc. As I think there's text that Bob was talking about this morning. We can probably use that. Add a note on support for DNS SD. As sort of co-chair of that group, I feel obliged that we should put something in there about that. There was a suggestion to add a note about happy eyeballs. I'm not so sure about that, though. I think that might be more of an application issue rather than a node thing, so probably not do that one. We're certainly, the authors believe we should add a new section on constrained devices. Again, we've heard something about that in this session, but there's a bunch of other things that we can add in there, pointers to for specific considerations for constrained devices. Maybe another one that's a little bit contentious is whether we should have a section on what layer 2 devices might be expected to do. Again, I'm not so sure about that. We've discussed it. We're not clear. It'll be interesting to get your views on that. So things like whether layer 2 devices should be doing things like RA guard, DHCP guard, those types of things. And things we might want to de-emphasize since the deployment experience of them is limited or very low. So things like jumbograms, send, and host-based mobility. The current thinking amongst the author team is to certainly de-emphasize those unless people have objections to that happening. So that's the sort of things we're planning to do amongst the 44 things we've identified so far. The other thing we've noticed just recently before the cutoff deadline, there was a new router requirements draft published, which is actually a really interesting read. It's more focused, it's not so much in the style of node requirements, which is more what things you should be conformant with some mays and shoulds and musts. This is more of an operational deployment guidance document for routers. It's a good read. I don't think not sure if it's being presented here in Seoul or not, but we've contacted the authors and we'll be trying to keep things in sync between the two documents, but we don't think there'll be too much overlap. But we have that in mind. So that's it. We're bashing away on this, myself, Tim, and John. So if you've got any comments for things you think we should be adding or anything you've read in there, I know what Lorenzo is going to say because he warned me already. Please come to the mic or send things to the list. Thanks.
This is Alex Petrescu. I could also send it to the list about de-emphasizing host-based mobility. Well, you could de-emphasize. It means it may come down what means to be emphasized or less emphasized, but don't remove it. We use it.
Okay, well, within the author team, we were discussing the level of support for that amongst common operating systems, for example. I guess I'm not aware of support, or we're not aware of supporting common operating systems. I guess there's products that do it.
There are some open source packages available on the web for host-based mobility.
Okay, I'll put that one to the list and we can discuss it there maybe.
Okay.
Lorenzo Colletti, so for happy eyeballs, I think the happy eyeballs is not is not an IPv6 requirement. It's a requirement to make things work in a mixed address requirement environment. So at least as specified. So I don't know that it should go in here.
I agree.
A couple of things. So yeah, so the 6434 has a statement about because different networks may use different addressing architectures, hosts should support HPV6 address assignment. So 7934 has clarified that for general purpose hosts, DHCP6 only networks are not recommended. And so I think we should border down that should to not necessarily to may, but to scope it to devices that intend to connect to such networks. Because in the general case, we're saying that that is not, sorry, in the general case, we're saying that DHCP6 only networks are not recommended. So you can use DHCP6 for certain things, address assignment I'm talking. So for example, if you want to have a stable IP address, or if you want to appear in DNS. So for example, if you have privacy issues that you don't want to do that, then it will be good for you. You have a good reason to ignore that should, but we might want to scope that should instead in this as we spin it. Another thing is, what does this say about RDNSS? Does it say anything?
I don't think it's got anything in there at the moment, so I think that needs to go. I would say that needs to go.
Does it say anything about RDNSS? What does it say? Dave Thaler says.
I don't think 6106 is in there. It's too recent, I think. Actually, no, that's before 6434, isn't it? So it should be. It should be in there.
It's a should.
Okay.
So
you're happy with that?
No, it should be must, but.
Okay, so responding to the DHCP comment, I think we should definitely add a comment about the new prefix per host thing, and part of that can be also reworking the text and, as they say, send text. So.
Fernando, I was going to ask about recursive DNS server option, but that was answered already. And the other one was, you mentioned DNS service discovery. What's the text that is text being added?
Well, no, at the moment it's just a comment saying we should add something that nodes may, well, we'll have to decide what the text is, but certainly something to point to DNSSD and say that nodes may wish to support this for service discovery.
Okay, cool.
But at the moment it says nothing about that as far as I remember.
Michael Richardson. Lorenzo, was it your statement that happy eyeballs would be unnecessary in a v6 only environment? Was that what you tried to say?
I believe as specified, yes, it is.
So I guess my contention is that that mechanism lets us intelligently choose between ULAs and GUAs and other things for in a v6 only environment where we could have a large number of possible source addresses. It picks the one that works. And I think that's really useful, and I think we need more of it, and I think we need it in not just browsers. So that's why I wanted to be clear on what you're saying exactly, because I think it's something that's really important in this space, in this host requirements.
So I'd like to clarify that as specified, okay, the text that we have on Happy Eyeballs, the title of the RFC is Trended Towards Success with Dual Stack Hosts, right? So if by Happy Eyeballs you mean throw everything at the wall and see what sticks, that's not what we have written in the RFC. So so if we want to write up a document that says throw everything at the wall and see what sticks, we can do that. We can amend 6724 and so on. But let's not say Happy Eyeballs, because as defined, that term means v4 versus v6.
Well, there is also the Happy Eyeballs in the sort of MIF sense of Happy Eyeballs. I think there's a draft of multi-interface Happy Eyeballs.
Well, MIF is dead, so I don't know where that went.
Well,
sorry,
I was just making a comment. It's not
the multiple interfaces working group is closed.
Okay, but Happy Eyeballs, there isn't just the dual stack Happy Eyeballs. There's the MIF Happy Eyeballs. Whether that died or not, I don't remember. But
okay, so to answer Lorenzo, there is actually the draft on the IESG. So for the MIF Happy Eyeballs, I'm holding a discourse on it right now. Okay, so just as a different point for the DHCP only thing, right? So the way 6434 is written today, there's no way to have a DHCP v6 only host because Slack is a must. Okay, so that takes care of your problem, right? Without any text changes. Like if you want to make text changes, that's fine, but the Slack must gets rid of like DHCP v6 only for addressing.
yeah, well, modulo things about 7217 as well, but yeah.
No, so well, not really, because I think as a host implementer, right? You know, there's guidance that you should do this, but in some cases, a host, you really don't want to do this for privacy or other reasons. And so it's, you know, that should is there and it causes lots of grief. But, you know, you know, in some cases, like I said, we should scope it to hosts that need particular functionality. Yes, you can't build a DHCP v6 only host, but because you also is not recommended to build a DHCP v6 only network, it doesn't make sense to say that hosts should implement DHCP v6. Right, necessarily. They should in certain cases, they don't have to.
So again, Suresh Krishnan again. So like there's actually like a lot of work done. I know you read the draft, like we made some comments, like changes for you. So there was a draft in DHCP v6, right? For the privacy considerations for DHCP v6, right? Where we actually talked about how things can go wrong and how you can actually use DHCP v6 in a better way, right? So I think like we covered the problem space. Like if there's something you want to add, that's fine. But like I think we covered like, okay, so these are the issues with using DHCP v6 like in the privacy case, and this is how you fix it. For example, like make a new DUID, right? For example, right?
So actually what that RFC says is that you should prefer stateless over stateful. So it means don't do DHPV6. That's what it says.
Yeah, I added the text, yes.
Right, but then if it says that like avoid DHPV6 privacy concerns by not using DHPV6 address assignment, then it's the same, right? It's the same as saying it's not recommended. Because that's what it says. It says stateless addressing should be preferred over stateful addressing. That's what it says.
Right, but it says there's a disclaimer which says hosts that are concerned about the privacy must do this, right? If you want to get your name in DNS, like you said, right? So okay, right. That's what I'm saying. We can scope it, but the text is already there somewhere. We can probably reuse the text. That's it. Okay.
Jumping back to happy eyeballs, I think ULA case shouldn't be covered by happy eyeballs because the default address selection should take care of this. And I hope, I don't know, are you referring that host must do the default address selection properly, right?
I believe that's what it says.
Yeah, okay, yeah. And you're referring to multi-homing host document as well, yeah, because it makes it slightly stronger in terms of mapping next hop to a prefix.
Yeah.
So in this case, yeah, I do not think happy eyeballs as they are it's defined now, yeah, helps.
Yeah. So I think that draft will be an RFC by the time we get this out, I think, what Bob was saying.
Yeah.
Yeah. But yeah, we might make a note that there are slight differences with the way 6724 works from 3484 and the implications of that maybe. But you want to try and minimize the text in this. We don't want to start writing big essays, I think. Okay, looks like.
And Tim, there's also two errata that you should look at.
Sorry, there's
two errata on.
Thank you for that reminder. Yes, I shall go and note that down straight away.
Excellent, thank you.
Thank
you. So, thank you. Pierre, you're up next.
Hello, everybody. So I am here today to tell a little bit about what's going on in beer. Closer to the mic. Better. Cool. So I will talk to you about what we are doing in beer. This is a draft I presented yesterday in the beer working group. It looks like there is a good support for that work. The idea is not to get that work done here in 6Man, but because this work is a bit related to IPv6, because it's about beer over IPv6. I was asked by the beer working group to come here and try to get some feedback. The idea being to get feedback as early as possible. Rather than IETF last call, to make sure that the 6Man working group, IPv6 experts don't have any concern about this approach. So I'm sure many of you know about beer, but I'm still going to recap a little bit what this is about. Beer is a new multicast routing paradigm. It doesn't make use of multicast addresses. It doesn't make use of groups. The idea being that you put a bit string in every packet that you want to forward, and each bit in that bit string addresses one destination, one potential destination. And when the bit is set to 1, that means that the packet is supposed to go to the destination that is associated with this bit. Meaning that if you set 101, that means that you want to send the packet to the destination, the first destination, not send to the second one, and send to the third destination. The advantage of this approach is that you do not need to keep state per group in the router. You just need to keep an overall state of your set of possible destinations. And the intermediate routers do not know about the groups. They just forward packet based on the bits they see and the unicast forwarding table. They do not have a multicast fib in that case. So this is an example of what's going on. You have everything happens in a beer domain. It's you do packet replication in your domain. You receive a multicast packet, like classical multicast packet on the left side. You encapsulate that packet in a beer encapsulation, and that beer encapsulation includes the bit string that you're going to use. And so depending on the bit string that you put at the egress, your packet is going to get replicated within the beer domain, such that it reaches the beer forwarding egress routers which bits have been set to 1 in the encapsulation. So this is the MPLS header, just to give you an idea of what it looks like. You see there is entropy field, bit string.
Clarification question.
Sure.
Can you go back?
Yeah.
Because I'm a dummy. What does that mean? Like, how do I know that bit 1 it corresponds to that router? Like, is that, you know?
Yeah, that's control plane.
Okay. Well, okay, but you know, does, like, when that router sees a join, it says, I want to see this group.
Yeah.
So the router knows what clients behind it want to join.
So it's not. You have to understand that all this has not been specified in the idea of having host doing MLD and so on. This is for transport of multicast traffic in a transit network. So you have a magic control plane that decides this group has to go to from these ingress routers to these egress routers. Do that, please.
So then the number of bits has to be the same as the number of routers, or the number of different group combinations have to be the same number of routers?
So you have a few tricks, like I don't know if it's here. No, it's not. But you have a bit string, which is a given length. But then you have set IDs, which allow you to have more bits than what's actually in each packet. So you can send a single packet to up to, like, I don't know, it can go up to 2,000 if you put 2,000 bits in your packet. But you can address more than that, more routers than that. So what about IPv6? Yeah, go ahead.
Another clarifying question. When it in the decap phase, how does it know how to return the destination to the? I assume it returns the destination to the multicast, to the original.
Yeah, it's encapsulated. So in that case, in that particular case, the multicast packet is still within the
and its destination address is unchanged.
Yeah,
I see.
Yeah, it's like IP in beer.
Right. So Dave Taylor, so if I understand right, the controller, or whatever you're calling it, has to have complete knowledge of the set of exit routers, the set of multi-QoS group joins, so that it can tell the router on the left how to map between this multi-QoS group and the set of bits.
Yeah.
Right. You got to have complete knowledge, and so in that sense, it'd be similar to, I think MOSPF had something sort of similar that assumed complete knowledge across the area, such that the sending router could then know which egress routers to send it to.
I have a draft as well that kind of proposes to use MLD instead of a centralized controller, but that's just a draft. I don't want to talk about it right now.
Right, but it has to be shared knowledge across everything in the domain, or at least somebody has to be able to tell everything in the domain, whether it's distributed or centralized.
Yeah. It's not.
Cisco. So the easiest way to think about it is that each bit position is really a unicast destination address, right? And you can. Well, it's unicast destination address of the egress router. Yeah. So, and those packets in the middle of the network, they follow the unicast destination towards that router. Right. So you really use unicast forwarding to route that bit. We just summarize the address into a single bit, and we can put multiple into the packet. That's basically it.
I didn't even start talking about IPv6. Now we start. So the beer working group is an experimental working group, meaning that everything that comes out from this working group is experimental. And it's chartered to specify one encap, which is the MPLS encapsulation, which has been combined with the Ethernet encapsulation. So the beer working group already has some work for MPLS and Ethernet. And it's chartered to provide one other encapsulation. I think that this one or other encapsulation should focus on IPv6, should focus on IPv6 only networks, the places where people want to have a future-proof network and do not want to deploy MPLS.
So I have a small question. The charter says that this is experimental work, but your draft says standards track.
Oops.
Okay.
Thank you. Will be fixed. Yeah, right. So I see two options to solve this issue with IPv6. I mean, focusing on IPv6. Greg?
Just address that right there. Our charter is experimental. The intention is we have a path to standards, so he will have to make the modification if we adopt it. But the full intention with this forwarding plane is a replacement for multi-point services we have today. So wow. Upon our success of showing interop and the scaling properties that we think we're getting with the solution, we are hopeful that we'll get everything on standards track. I want to address Daler's question too, and paralleling this to MOSPF, and I think that's quite a misconception that the intermediate nodes have no concept of membership at all. They just have topology information. So the only membership, in fact, unlike PIM we've had before where the two are coupled, beer is totally separated. We just got multi-point replication fabric topology information, and any sort of membership is signaled over the top.
The analogy that I was drawing is that the sending router has to
Microphone, please.
Yeah, yes.
That's the analogy. MOSPF has that property.
Okay, thanks.
So can you summarize this discussion, please?
He was paralleling MOSPF in that the edge router has to have full knowledge of the exit routers, not necessarily that all the intermediate routers have membership state.
Right. So I see. Well, can we keep the question later, because I think we have only 15 minutes.
Yep.
I mean, maybe no 5 minutes left, something like that. So there are two options really. I see two options. One is using a hop-by-hop extension header, or an extension header which would have similar operating mode with regard to the beer routers. The other option I see is to just reuse the IPv6 header. That's the option that is used in this draft, because I mean, using a hop-by-hop header has many implications, so I didn't really want it to go this way. And the solution is really simple. I mean, this proposal is really simple. It just uses the destination IP address to put the beer bits within. So you cut your source destination address in two parts. One part is to identify the fact that the packet is a beer packet. You also is able to identify that the bit set ID I talked about and the subdomain ID I talked about. I mean, different information that are a bit beer specific. And in the second part of the packet, you put the bit string. Yes, Lorenzo?
Clarifying question. So beer IPv6 prefix, does that have to be, is that a unicast prefix that registered with an RIR?
It's not, yeah, in this draft at least, it's proposed that it could be any global or ULA, or yeah, any global or ULA.
So ULA is it's a 48, right? And if I, so I guess does that mean if I need 96 bits, does that mean I have to request a 32 from my RIR? If I need, 120 bits, do I need to request a /8 from my RIR? That's the question.
Yeah. Yeah, I mean, you need, if you want many bits in your bit string, I mean, if you want a bit string of 100 bits, then you need a very short prefix.
Then you need a 28. Okay, thanks.
But I would not advise to do that. I mean, I think many use cases here could very well work with 64 bits or so.
So if you wanted 128 hosts, you'd have to use the whole IPv6 address space?
No, that's the idea. Beer supports the two concepts. There is the subdomain, so you have a subdomain ID, and you have the bit set ID. Really, the difference is that subdomain ID gives you a configuration mapping, which allows you to have more bits, and the bit string ID, the bit set ID gives you algorithmic binding. Like if you have 64-bit string length, then you are going to cut your space, and you have the set ID 1, the set ID 2, etc. So you can have more hosts. I mean, more routers.
Dave, are you going to show where that would be encoded in the IPv6 proposal? Because it's not on that slide. So no. This slide only talks about where you put the bit string bits, which maxes out. You're saying there's a different set of bits that would not be in the IPv6 header. Where would that be?
Yeah. So that's in the beer IPv6 prefix. So there is no need for a fixed length field. The idea is that you perform some sort of longest match. I mean, you get an IPv6 packet. You do longest match prefix on that packet, just like you do with any unicast packet, and that's going to give you the entry that you found. That entry is going to, if it's a beer entry, it's going to be associated with the bitset ID, with the subdomain. So you get all that information just doing the regular IP lookup.
Lee Howard, I think so. There's some level of hierarchical routing required, because you've got a subnet ID or subdomain ID, and then a set of routers behind that that are identified by the bit set. I could just go read the draft, but I haven't had time yet.
So no, really, in the previous version of the draft, there was the first part was cut into 3 parts. There was the prefix, there was the subdomain ID, and there was the subset ID. The set ID, yeah, the set ID. That was removed because we took the same path in the MPLS encapsulation, because we sort of realized that it was not necessary to hard code it in there. The important part is that when you forward the packet, at some point you get that information. That information is provided to you by a mapping between the prefix and that information. So you get it. It's configured. You would need to configure it anyway. You cannot have a fixed. You cannot. Well, you could use a fixed field, but it's very constraining for no actual reason.
Do you have more slides or?
Yeah, I do.
Okay.
So this is an example. Yeah, I'm going to go quickly through the other slide. And, yeah, and then I will take the questions. So this is an example. You get a multicast packet. You encapsulate it in a IP beer packet. Can we keep it to the end?
Is 1 + 2 + 4 + 8 = E?
I made a mistake?
No, is it? Is it? Yes. Okay. Thank you.
Yeah, it's okay.
Yeah, that's okay. Thanks. That's the idea. So you set it to E and okay. Yeah, right. So you assigned the bits to the egress routers, and in that case, you can represent that assignment with an IPv6 address assignment, because you have an IPv6 address with the beer prefix first, and then you have just one bit that is set to 1. So 1, 2, 4, 8. So you send the packet to like for instance 2001 E. That means that you send the packet to the first, the second, and the third. I mean, the one on the top, the second one, and the third router in there. The last one router, just like in the other example, will not receive the packet. So the advantage of this is that it works in IPv6 only networks. You do not need to deploy MPLS. It doesn't use extension header. I see it as an advantage because from that it's compatible with existing extension headers, just like IPv6 segment routing and maybe others. It supports IP and IP encapsulation, but it could also be used for other encapsulation, possibly. I mean, that needs more thinking, I think. And is this the new version of the slide?
It should be.
Okay. Okay. So and yeah, I don't think so. I think it's not the latest version.
Right.
So what I added was that it offers some sort of backward compatibility with the host, meaning that a host can send an encapsulated packet using IP in IP. And that packet can be a beer packet, and the host doesn't need to know it. The host can send a packet encapsulated in IP using IP in IP encapsulation, classic one, and the destination address happens to be a beer address. So the packet can cross some part of unicast network, reach the beer domain, and from that point on, being considered as a beer packet, being replicated. Same thing applies to the destination. If instead of your egress router, you put a host that accepts IP in IP encapsulation, then when it receives the packet, it's going to receive the packet with the IPv6 prefix and just one bit set to 1. So it's going to consider the packet as for its own, like any unicast packet. The cons of these proposals are the limited size of the bit string, and that the fact that the IPv6 destination address is modified. I mean, the outer header destination address is modified. So what I would like to know is whether this is a good idea or not. Should we investigate a solution which uses extension headers, like hop-by-hop extension headers, or should we stick with it? Or maybe you can also tell that we shouldn't try to make it work. I mean, try to make an IPv6-based approach, but rather stick to layer 2 or whatever.
So we have about 3 minutes for discussion. So I think we'll cut the mic line there, and if everyone speaks quick and briefly, that would be great. Thank you. Go, Eric.
So Eric Nordmark, I think hired a bit. I think it's useful to explore this, right? The last question on the slide, doing this for IPv6. The thing I don't know is sort of, is having this limited number of bits, whatever it might be, 64, 80, whatever, 96, is that still useful in beer? But that depends on how beer is going to be deployed and what's the size of these domains, right? So it's a bit disconcerting that when you're doing this stuff with MPLS, you have 2,000 bits or something, and here you have a lot less. Is that going to make this not be useful at the end of the day? But yeah.
So very quickly, this may apply to networks where you do not have a big MTU, like other kind of networks. What's interesting as well is with this approach is that it may apply to use cases that are not concerned by the MPLS MCAP, like other cases, like maybe in data centers or smaller networks. I mean, I honestly think that could be used in HomeNet as well. for if we want to provide multicast in OMNet, this kind of thing.
So given the size of the line, how about if people at the line state their comments and then you can respond, offline, because we won't have time to go through them interactively?
Hi, Tom Herbert. Just one comment. I'm wondering if you're, say, multicasting UDP, how do you keep the UDP checksum sane if you're modifying the destination address?
It would need to be updated.
Yeah. Microphone, please, and next.
Xiaohu from Huawei. First, I would like to say it's a good attempt to design a direct approach or beer encapsulation, which is totally different from the original MPS beer encapsulation. Since it doesn't require indirection lookup for the necessary information for beer forwarding. However, beer, in my opinion, is just another network layer handler. So it seems unnecessary to tightly couple it to IPv6. As it has been mentioned by Eric Rowden in the beer mailing list, it has many limitations and shortages. The only benefit I can sort of is technical benefit is it can traverse non-beer domain. Of course, is there another benefit, which is non-technical benefit, is create more job opportunities for protocol designers.
I think we'll move on. Suresh, thank you. We don't have to discuss job opportunities here.
Suresh Krishnan, short comment. The example you gave is good, but it's very contrived, right? Like, it shows like a very clean split of the topology, right? Like, so there's no cross links, like there's no multiple paths to an egress router. I want to see how the destination address changes. Like, you had a C and a 2, right? What if there's a C and a 6, or a 6 C and a?
To make it short, you need to read the beer stuff. That works. That just works.
No, like, yeah, but there's a unicast. You're forwarding unicast v6, right?
Using beer forwarding.
Okay.
It works.
Okay.
Lorenzo Colletti, I think I would instead, so I would observe that if you want to use this in anything large, you're going to have to request a very big prefix, and even there, you just like there may not be enough bits in the IP address to do this. And now you could use the source address if you wanted to, but you could basically what you want is you want a part of the packet that you can scribble over, right? It doesn't have to be MPLS. I would say the extension header is a better option because it's more extensible. You can get hosts to do it. It requires a little bit more work, but to be honest, I think it's not easy on unmodified hosts to insert IP headers already. So you would need some modifications to hosts even for this. So I think because this by definition has to go into a domain where every router has to be updated to be a beer forwarder, I don't see a downside of having the extension header option because you have to touch all those nodes anyway.
The hop by up or another one?
But okay, so the packet size is literally linear in the number of bits that you put. There's a lot of wasted bytes in the IP header because it's 40 bytes long and you only have whatever bits.
Okay, we have 3 minutes.
Lee Howard, I basically agree with Lorenzo. The basic design principle, I'm trying to decide between the simplicity and the complexity and whether they outweigh each other. As a basic design principle, I don't like embedding semantics in identifiers. And here, you're sort of embedding routes as a semantic in the identifier and conflating the two. There's a lot of philosophy we really want to be very careful of there before we go embedding routing information in destination address. So that kind of scares me. But I think, and I want to see some math. I haven't done the math on how many potential and the potential depth of the network that we could handle with the number of bits available. So that's partly in response there. Thanks.
David Lamparter. So I disagree with all of the comments that go in the direction of there will not be enough bits for a properly sized network because the bits are scoped to the prefix, and if you need more bits, you're just going to use more than one prefix, and you're going to have all of the bits twice or 3 times or whatever. And that's no problem at all. You just will need to send the packet 2 or 3 times at the first ingress router after encapsulating it. So you can have as many bits as you want by by dividing by 64 and then using more than 164 for this purpose. They'll have different meanings, but let's take this offline. I actually have a separate comment. There's an option missing here, which is that if you're encapsulating, which you need to do anyway because you need to restore the original destination address, you can also put the bits in the encapsulation. So that wouldn't necessarily be a hop-by-hop header, but could be part of the encapsulation itself. So I think that might be worth considering.
So we really cut the line off today, but if you're super, super quick.
Jelinkova, I think it would be interesting to see extension header, but we already spent an hour on the topic, so it's kind of risky. I'm just curious, is there any reason we can't request a special well-known prefix for this?
Yeah. That's a question. Take it on the list. Mark.
Mark Townsley. I just wanted to, there's been a lot of comments about this. The ones that are, oh, should we just use MPLS or should we use V6 for beer, especially when beer isn't fully understood, are the ones that really should not be considered in scope for this discussion. Yesterday, this was presented in beer, and there was pretty strong support for IPv6 or layer 3 solution as the other solution next to the MPLS one, okay? And that's pretty consistent with what we see in segment routing. There's an MPLS one, there's a V6 one, or VPNs, there's an L2 VPN, there's an L3 VPN. If beer is going to exist as an experiment, experimenting at L2 and experimenting at L3 makes sense. This working group needs to, give advice to the beer experimental working group on the best way to conduct those experiments and what works with V6 and what doesn't work with V6. So things like extension header versus destination address, fine. But should we do this at all in V6?
So that's what
more
we're,
for beer.
I agree, and that's what we're doing, is giving feedback.
Greg Shepard, I just want to address the question about number of bits, because you said like 2,000. The architecture allows increments in 64, 128, 256, on and on. The target we're going right now is 256 bits as the current implementation in MPLS. And a lot of this has come back from operators. They said, is that enough? How many bits do you need? The truth is, from what feedback we've got, I think about 80% of the use cases are fairly well covered with 256, but it's certainly not linear, right? That last few, they're looking for thousands of them, so in some cases 10,000, and we know we're never going to get that into a header. So just kind of give you a target what we're after. If there's a particular use case we're going out here, I think like Mark said to us, experimental, it's a nice size to still be functional to get us something out there to play with.
Okay, thank you a lot. We're certainly, going to look at this. It is an experiment. I think we're positive to that, but we're not going to let the experiment burn the whole V6 address space. So Tim, do you want to quickly run through the issues that came up with the Yang models for the IPv6 RA?
Hi. So this is just hopefully a very quick item. I think we're just looking for, assuming the working group wants to take this on, a volunteer or two to actually do it. So next slide. So for reasons I won't go into, I was reviewing a draft in the NetMod working group, which is defining a number of modules to allow configuration of routers. One of the submodules within that quite lengthy draft up there is one that defines parameters for configuring IPv6 RAs, the submodule up there. However, there was a decision made within NetMod to only include the parameters that are defined in 4861. And you can see that in section 5.4 of the draft. The idea being then, and it says it in this draft, that if other working groups want to define extra things, they're welcome to do so. Next slide. So the problem with this approach, from our point of view, would be that if you want to use this approach to configure RAs in routers, then you would have no way of expressing the 4191 options or the RDNSS options, or potentially some other things that I may not yet have thought about. I think there's probably some of those. So the question is, A, should we fix this? Do we care? And B, if we do care, I would hope that we do, is there someone that wants to take that on? The co-author of that draft, Lada Lotka, has said he's happy to work with someone from 6MAN who's Yang savvy to define that if you want to do that. So that's basically the question. That makes sense.
Yeah.
Qualifying question: did you volunteer or did you not volunteer?
Could be, but the point is, I'm sure there's better people in the room than me to do Yang stuff.
It does seem that we should fix this because it's not useful to represent an RA if you don't have these other things.
Exactly.
Right.
Michael Abramson, yes, this should definitely be fixed if it can be configured, or if you can emit it on the wire and someone needs to configure something to change how this does, it should be doable using Yang.
So I raised this in the review, but the answer from the AD, whoever it was no, you need to do that in your own way.
So Michael, you know Yang, right?
What are you accusing me of?
Good, thank you.
Suresh Krishnan. So if we are talking about the same document, this document has already gone through the ESG. Okay.
Well, I was reviewing it as part of that. Yeah.
Okay. So I brought up like similar concerns to this, and the answer I got was like, you do it as an extension to this model, because there's like about 25 other documents waiting on this, and so we're not going to hold it for you to give us comments. So that's the comments I got back from the ops AD. Okay, so I said, okay, like I'm not going to put a discuss on this because like, you know, like they're going to fix it later. Okay, so, and since it's Yang, it's extensible. So I don't think we are on the critical path here. Okay, because I think this document is through, and we put in a rush for a new RFC number and so
I'm
on.
not saying change that. I'm saying another document.
No, I'm just saying, right? Yeah, exactly. So like Michael can work on the new document with Tim.
Yeah, so I should have been clear. It's not changing that. It's a new document to add the extra things.
Right, and because it says, should we fix this? It's unfixable at this point.
Yeah, sorry, that was a bit confusing. So.
Okay, good. I think that concludes the session for today then. I have no idea where we're meeting next.
Chicago.
Oh, yes. Oh, no.
So we are done. Thank you very much. See you all in Chicago.
Let's see. I should go and oh, now we suddenly had 4 minutes left. Well, but it was.
That was fine.
Yeah.
It wasn't going to resolve.
You got notes?
I just sent them to you.
Yeah. I think so? Eric, did you do the notes on Etherpad? And yeah, do you want to clean those up, or can we take them verbatim?
This is a usual